Welcome to our YouTube channel. Myself Manjunath Hegde, lecturer in chemistry, Department of Chemistry, SEM College Manala. Today I talk about one of the important concepts in polymer chemistry, which is under the M.Sc second SEM in general chemistry syllabus, described in the second semester syllabus. Is a under the polymerization concept. One is the important concept is free radical. Free radical polymerization. So before explain the free radical polymerization, what is meant by free radical polymerization? So it's a process reacting of monomer together to form a polymer chain. That process is nothing but polymerization. So what is meant by monomer? These are the basic concepts. The monomer means single unit functional molecule containing a single functional group. So in here, one of the important concept is under the polymerization, free radical polymerization techniques. Then what is meant by free radical polymerization? And polymerization or this process initiated by the free radicals or a molecule like monomer, it will be cloud together to form a polymer chain with the help of one of the material like free radicals. So in here the initiation is a word, it explains free radical polymerization. The polymerization initiated by the free radical, that is called as free radical polymerization techniques. So in here, how its free radicals are generated? Because of in the every reactions, it's one of the external substances like either called as catalyst or like an reactant or like a solvent. So in here, the important concept is free radical. How free radical will be generated or produced. So in here, these free radicals are produced by the decomposition of the compounds. That is called as initiator. So these free radicals generated by the decomposition of the compounds. So these decomposition either by the heat energy or by the light energy or by the catalyst. Either in one of the external energy they adapted on the molecule like the initiator molecule, it will decompose to produce a free radicals. These generated free radicals can initiate the polymerization reactions. So in here, what is meant by initiator? So the initiator means it's a chemical substances or thermally unstable material. It would easily decompose by these energies, either the heat energy or the light energy or the catalytic energy. So these like the example for the initiators is azo compounds. Azo means N double bond N compounds or called as azo. These are the azo groups. The example for the azo compounds like N double bond N, so the compounds containing N double bond N, that is called as azo compounds. It's one of the example for the initiators. So in here that is an example for bis azo diphenyl methane. That is the name of this initiator. it would get decomposed either by the heat energy or light energy or the catalytic energy. It would it produces the free radicals. So either heat energy or the light energy or the catalytic energy, it would get decomposed to CH radical plus liberation of nitrogen. So that is the example for the azo compounds. And next is not only the azo compounds but also peroxides and peracids. Example for peroxide is benzoyl peroxide. C double bond O, C double bond O, C6H5. That is benzoyl peroxide. This is one example for the initiator. These are thermally unstable material due to the heat energy or light energy. It would get decomposed into C double bond O radical or benzene free radical or benzene free radical. So it would produce either the COO radical or the benzene free radicals. It depends on the light. By using light energy, it would directly decompose to benzene free radicals, or either by the some amount of heat should be applied. In that cases, it will be decomposed into COO radical. As temperature increases, again it decomposes to benzene free radicals. That is an example for the peroxides. And next one is peracids. Example is CH3COOOH. Peracetic acid. One is an example for the peracids. It is also a thermally unstable material. It would get decomposed to CH3 radical or OH radical or CH3 C double bond O radical. It is also a variation of formation of radical by the change of its heat energy. So these are an example for the initiators. Either by this decomposition of initiator by light energy, heat energy or the catalytic energy. By using these initiator, it initiates the polymerization reaction, that is called as free radical polymerization reactions. So the another mechanism of polymerization, mainly there are the three steps. One is initiation, next one is propagation, and third one is termination. So these three are the main important steps which involved in the polymerization. All type of polymerization reaction like free radical, ionic polymerization, Ziegler-Natta polymerization reaction. In all the cases, these three are the important steps. One is initiation, propagation, and termination. So before initiation, it must require one initiator. So these initiator decompose to produce the free radicals. By using these free radical or these free radical will attack the monomer site and it produces the initiation. So we can discuss about one by one steps. First one is initiation. Before initiation, better we can discuss starting from the initiator. So one example is benzoyl peroxide considered as an initiator. It produces the polymerization of vinyl polymer like vinyl chloride. Because free radical polymerization commonly used to polymerize the vinyl compounds. Vinyl compounds means C double bond C compounds. So in here the best example is CH2 double bond CHCl, vinyl chloride. It's an example for the free radical polymerization. Consider the free radical polymerization. That's why the one of the initiator is benzoyl peroxide. C double bond O, C double bond O. The benzoyl peroxide, by the help of some amount of heat energy, it produces the C double bond O free radicals. These free radicals, by the initiation step, it produces the initiation reaction. The first step is initiation. So the initiation, the monomer is vinyl chloride. Means in the free radical polymerization, the monomer containing carbon to carbon double bond that must require, and these 5 electrons will distributed these electrons and formation of polymer chains. So the at the first, the initiator or the generated free radicals will attach the 5 electrons clouds of the monomer. So here these 5 electrons, for the representation purposes, it can be written as C double bond C, CH2 CHCl, C double dot. The double dot indicates the 2 electrons which are involved in the carbon to carbon atoms. That's why in here the 5 electrons will diverse effect because of these generated free radicals will active species. It always looks for the another free radicals or another of the 5 electrons. That's why these 5 electrons, one electron moves to the free radical side and another one free radical moves to the opposite to the top side. That's why the initiation starts. The initiator will form the sigma bond between initiator to the first monomer side. That's why CH2 CH, because of the 5 electrons will be disturbed or diverged. That's why one electron shifted, formation of sigma bond between initiator to monomer and generation of free radicals at the end of the monomer side. That step is nothing but initiation. In here, these 5 electrons are diverged due to diverse effect. One electron shifted to the radical side and another electron moves at the end of the polymer chain and forms the initiation reaction. These the initiation step, generation of free radicals at the end of the polymer side will always active species. It will attach the next added monomers. So the next comes under the propagation. In propagation, that is the continued part of free radical initiation step. Under the initiation reaction, C double bond O CH2 CHCl, generation of radical sites at the end of the monomer, it will always active species. It will attach the 5 electrons clouds of the next added monomer. Because of polymer is more number of monomers or more repeated units. That's why the repeated units we can add more number of monomers. Polymer chain should be length. When we add a small amount of monomer, the polymer chain should be shorter. That's why the next added monomer, these 5 electrons again due to the diverse effect and one electron shifted to the end of the monomer side forms the propagation reaction. CHCl, CH2, CHCl radical at the end of the monomer side. So in every step of propagation vinyl chloride, automatically the polymer chain should be C double bond OO, CH2 CHCl and times CH2 CHCl radicals. So the n number of monomers can be shown in the form in the representative of. These are the R group. R means the beginning R means radical or R dot is radical. It can be in here in these considered cases benzoyl peroxide as R. That's why this CH2 CHCl n number of and its number is end of the polymer chains for the representation of free radicals. It will show the CH2 CH radical CHCl radicals. And the next, once propagation completed, the last step is termination. Termination, the word explains to kill or to terminate, to arrest the growing polymer chains. That is what as termination reactions. So in here, termination reaction after propagation reaction, under the propagation C double bond O CH2 CHCl and times CH2 CHCl radical. That is the propagation. In the beginning we explained that the benzoyl free radicals are decomposed into free radicals. We observed that 2 moles of free radicals will be generated. So more than one free radicals generated, it starts the more number of growing polymer chains. For that, in the termination step, the 2 growing polymer chains colliding together. That's why another one growing polymer chains I have written in the reverse direction. CHCl radical. Next is CH2 CHCl CH2 and times O C double bond O. So combining the 2 growing polymer chains, the termination may take place. So in here, the first type of termination, the collision of 2 growing polymer chains. In here, sharing of the one lone electron from the each side forms the sigma bond between the 2 growing polymer chains, and the whole polymer chains to be arrested. So in here, we written that C double bond O CH2 CHCl and times CH2 CHCl, that is the one growing polymer chains. It will form the sigma bond between the next growing polymer chains CH2 CHCl CH2 and times O C double bond O. So that is the one type of termination. In here, there is no active radical sites. If it is the chain having the one of the free radicals, it is always active species. It will continue the growing polymer chains. Hence, it cannot be arrested. Termination is to kill the growing polymer chains, or after production, these polymer chains are dead polymers. These polymer chains are dead polymers. So in here, it will be terminated by the sharing of the individual lone electrons, forms the sigma bond between 2 growing polymer chains. So these type of polymerization reaction, is termination by coupling. Also called it as termination by coupling, means coupling of 2 growing polymer chains. And another one is the second termination step is the two growing polymer chains. Because of the generate more number of free radicals, more number of growing polymer chains can be developed in the reaction mechanism. The collision of these two growing polymer chains. So in here, one of the concept in the second concept is it will be written in the form of like that. The abstraction of hydrogen atom from any one of the growing polymer chains to the another radical site. Either abstraction of hydrogen from this growing polymer chain to that, or from that growing polymer chains to this growing polymer chains, and forms the sigma bond between these, or to arrest the one growing polymer chains. Like it will be written in the form of C double bond OO CH2 CHCl and times CH2 CH. Due to the abstraction of one hydrogen atom, it will be terminated, or it is in the form of CH2 Cl. And another one is due to the abstraction, these free radicals, it will terminated by the formation of double bond. It will get stabilized by the formation of double bond at the end of the growing polymer chains. So in here CHCl, one electrons from the radical side and one electrons from these free radicals. That's why CH double bond CH CH Cl CH2 and times O C double bond O. So these type of termination can be written as termination by disproportionation. That is called as the termination by disproportionation. In here, the termination under the free radical polymerization, there are two types of termination takes place. One is termination by coupling and another one is termination by disproportionation. So what type of monomer can be polymerized under free radical? So it will be explaining all type of vinyl polymers like C double bond C, ethylene vinyl chloride, or some other compound monomers like styrene, CH double bond CH2, that is called as styrene. These type of monomers can be polymerized under the free radical polymerization techniques. So in the above concept, why these type of formation takes place? Means after it produces the C double bond OO CH2 CH Cl CH2 CH Cl radical. Why this type of termination takes place? Is any other type of processes like another one is CHCl, like these are called as these CHCl CH2 radical. Is it possible? Yes. These type of polymerization contacts had to take type of polymerization, and these type of contacts take type of polymerization. In here polymerization processes, there are 4 types of way it produces the polymer chains. One is head to head, second one is head to tail, and third one is tail to head, and fourth one is tail to tail type of formation. So in here I will show you the very briefly. That is the growing polymer chains CH to CH, CN, CH to CH to CH, CL, yeah, CH, CL radical. That type of polymerization is head to head. That means what is meant by head? In the monomer like vinyl chloride, CH2 group is called as head group and CHCl called as tail group. Means the head of the fresh added monomer to the tail of the growing polymer chains, or in the first cases head to head means head of the fresh monomer added to the head of the growing polymer chains. In here CH2 is the head group. That's what in the growing polymer chains, head of the growing polymer chains and head of the fresh monomers. And the next concept is head to tail means CH2 CH Cl, CH2 CH Cl radical. In here the head of the group fresh monomer added to the tail of the growing polymer chains. That is called as head to tail type of polymerization. Tail to head means CH2 CH CH Cl, CH2 CHCl, CH2 radical. Tail of the growing fresh monomer to the head of the growing polymer chains. And another one concept is tail to tail, like CH2 CHCl, tail of the growing polymer chains added to the tail of the fresh monomer. So these cases, in generally all type of polymerization reaction always head to tail type of only. In the some explanation purposes, these type of processes or the way may explain under the polymerization reactions. So these three are the important concepts in the initiation, propagation and termination. These three are the important concepts in the free radical polymerization reactions. And under the free radical there are another two criteria. One is chain transfer and another one is chain inhibition. Chain transfer means transfer of like CHCl and times CH2 CHCl radical. In the after propagation reaction, chain transfer reaction like RH, either by the addition of new compounds or either by the addition of impurity or by some other compounds, the transfer or abstraction of hydrogen from the another compound to the growing polymer chains, and these growing polymer chains to be arrested, and simultaneously it generates another one free radicals. These free radicals may initiate the polymerization reactions. C-double-bond-O-O, CH2 CHCl and times CH2 CH2 Cl. That is the one growing dead polymers. That is the dead polymer. Simultaneously it generates R-dot. These R-dot may initiate the propagation reaction. That type of reaction is nothing but chain transfer. And another one is chain inhibition. What is meant by inhibition? To inhibit or to kill or to arrest the growing polymer chains. It may be permanently arrested or it may be temporarily. Generally, the inhibitors are used to temporarily P dot. P stands for polymer, dot stands for growing at the free radical polymer chains. It will, by the help of oxygen, is one of the best inhibitor because of oxygen is biradical, O dot O dot. These biradical, it will at the beginning POO dot. Another next monomer, next polymer chains, it will completely arrested POOP. That is the arrested growing polymer chains. These arrested polymer chains we can transfer from one place to the another place, or the reaction may continue from one day to the next day. These type of inhibitors are added in the reaction mechanism. So in here, that's why the free radical polymerization are always carried under nitrogen atmosphere, because of in the atmospheric condition, these atmospheric oxygen is acts as an inhibitor, will immediately arrest the growing polymer chains. So these are the more important concepts in the polymerization and free radical